Okay, thanks so much. All right, so welcome everyone, and thank you for taking time out to attend our latest seminar. For those of you who don't know me, my name is Catherine Murphy, and I'm the science coordinator for the Middle Rio Grande Endangered Species Collaborative Program here in Albuquerque, New Mexico. Today, we're very fortunate to hear from Stephanie Granger. She's a program manager and technical group supervisor at NASA's Jet Propulsion Laboratory in Pasadena, California. Stephanie leads the Applied Science System Engineering Group at JPL and is the program director for NASA's Western Water Applications Office, which provides practical applications of NASA data and technology for water management. She holds a BS from the University of Redlands, California, and an MS from the Claremont Graduate University in Claremont, California. Over a 30-plus year career at JPL, Stephanie has been involved in earth science remote sensing research, applied science system engineering, program management, and partnership development. She continues to work with a broad set of non-traditional user communities to understand needs and expand the benefit and value of NASA's earth science observations. This afternoon, Stephanie will introduce us to the Western Water Applications Office and, I hope, add some of our collaborative program participants to her list of partners. As usual, please use the Zoom chat to submit questions during her presentation, or you can wait and raise your hand to be recognized during the Q&A to follow. So with that, I'll turn things over to Stephanie.
Thank you, Catherine, and thank you for that introduction. I need to shorten it.
That's okay.
But thanks all for the invitation to present. We really appreciate the opportunity to be here today to talk about some of the great work that NASA is doing both in water, and I'll give an overview of the Western Water Applications Office, but also in ecological conservation. And I'll talk a little bit about
I can go now.
So first of all, I'd like to take a minute if I can advance the slides. Come on. Somehow, oh, there we go. Okay, sorry about that. Okay, sorry about that. I lost my cursor. So first of all, I'd just like to take a moment to recognize our team. This is our core staff. Let me get this out of the way. There we go. There's myself, Sharon Ray, who is our engagement lead, Amber McCollum, who leads sort of our project management as well as applications transition activities, Amber Jenkins, who leads information architecture and strategic communications for the WWAO, Mark Davidson, who's taken point on private sector engagement, something that we are very much interested in, and I see this is moving faster than I'm talking. Indrani Gracek, who is our previous program director and is now our ambassador at large. And we hope to have a science solutions manager and a program coordinator join us very shortly. We have a science team. This science team brings together complementary expertise from across NASA. Bailey Lee is a modeler from the Goddard Space Flight Center in Maryland. Renato Frazan is a hydrologist at Jet Propulsion Laboratory. Anita Mehta is a water quality expert, and AJ Purdy is an expert in consumptive use, ET, water use at Ames Research Center. So we really have a window into all of NASA. So just wanted to touch on this briefly. So although sort of NASA is probably best known for planetary missions like Mars rovers, much of the work that we do at NASA is for Earth science. And this graphic on the left shows many of the current and planned Earth science missions. And because we are a water office, I've starred those missions. It's hard to see, but starred with the yellow stars, those missions that contribute to water cycle science. So as you can see, aspects of the water cycle are a science topic for the vast majority of Earth science missions. Then on the right, it's just the 4 boxes represent the different aspects of the Earth Science Directorate at NASA. And since our creation over 50 years ago, we've worked to just push back the boundaries in missions, technology, science, and exploration. But what is perhaps less well-known is that we've also nurtured partnerships to transfer our technologies for societal benefit. And these benefits really reach throughout the economy and around the globe. And Western Water Applications Office is part of this, what's now called Earth Action. We're part of Earth Action at NASA. We really take advantage of NASA's capabilities to support decision-making for environmental challenges. I just wanted to give a highlight of the Earth Action or applied science. So these are thematic elements, and you can see on the right the different thematic elements that cover different areas in which Earth science information can serve society. WWAO is a part of the Water Resources Program. And so for today's talk, I'm going to give an overview of the Western Water Applications Office, or WWAO, talk a little bit about what we do, and an overview of some of the projects that we funded, and some a little bit into some of the projects that we'll be funding in the future. And then I'm also going to highlight, because I think it's relevant for this audience, another NASA program in the Earth Action Applied Sciences that's called the Ecological Conservation Program. And I have a couple of examples of some of their projects as well. So, sometimes when NASA folks go to meetings around, water resources, or at least this used to be the case. For me, I would hear, why is NASA here? And we really have been partnering with water management organizations and agencies for decades. And we're sort of harnessing the investment that the nation has made in these earth science observations, and for well over 50 years, and working to figure out how we can put them to use for water management. And because of the work that we've done with water managers, and particularly the work that we've done in the past through the 2012 through the American Recovery and Reinvestment Act, and various projects that were funded by the Water Resources Program. There's a couple of examples here: snow measurements, evapotranspiration, soil moisture, subsidence due to groundwater withdrawals. Because of this work that we were doing through these other funded activities, NASA recognized that there was a need for sustained engagement and projects in the West. And so the Western Water Applications Office was established in 2016 to build on some of these past efforts and to advance them even further. So I think we all know that that water availability in the Western US, and particularly in the arid Southwest, is drastically changing, fluctuating. And this really makes it difficult for a community that manages water based on past experiences. I'm sure as you all know, the stationarity paradigm for water management no longer applies under a changing climate. And so more and more what we're hearing from water management community, federal, state, other local entities, is they're looking for additional information that complements what they already have and fits into existing programs and projects, but additional information from satellite observations. And so our mission is to directly benefit water management in the Western US by working with water managers to get NASA data, technology, model results, analysis tools into the hands of the management community. And there's sort of three themes that we're organized around. One, the first is to identify. So we identify needs in Western water management, and I'll talk a little bit about the process that we've taken to identify those needs. We make connections between the water management community and NASA then to address those needs. I mentioned that our office has representation across several different NASA centers, and we offer as I said, a window. It's a window or a door into other NASA programs as well. And we also make these connections by funding projects. And then we work to transition successful projects and applications that we develop into operational use for longer term impact. So talk a little bit about some of our outcomes and some of what we do. Here we go. In terms of identity, I'll touch on these key themes just for a couple of times here. So so this box here just describes, some of what we've done. This is from our annual report. But really, in terms of identify, we work to develop strategic relationships with key stakeholders in Western water management. We conduct needs assessments, these basin-wide needs assessments, to really understand and identify the pain points, what's keeping people up at night, and what are the needs where NASA capabilities can provide value. And then we develop a catalog of these needs as use cases. And those use cases are on our portal. They're open and available for anyone to take a look at if they're curious. And then in terms of connection and connecting, we solicit, select, and we implement needs-driven projects that are either stakeholder-led, we've got some great examples in the Columbia River Basin, or that have a strong stakeholder engagement. We do this through an RFI process. We conduct needs assessments in a basin. We create the use cases. Once we've got those use cases identified, we craft a request for information where we connect to that RFI, and we ask for concepts or capabilities that can be brought to bear to address the needs that we identify. From those responses, we fund projects. And we conducted a needs assessment in the Rio Grande Basin about, gosh, it was a little less than a year ago now, or no, over a year ago now, I should say. And we published an RFI as a result of that needs assessment. And the RFI closed June 30th, and we've received a fair number of responses, and we're going through the review process of those responses now. Then we also, through this connection activity, we develop a catalog of NASA capabilities and tools relevant to water management based on the RFI responses, and then also we connect those to the needs that we've identified. And then lastly, we work to transition. So we do this by impact assessments. We assess the impacts of WWAO funded projects. And we identify pathways to transition some of the promising tools that we've developed for sustained operational use. And then we are working to establish a science to action community. This research to operations is not trivial. And so we're working with the federal partners and others and looking for kind of innovative ways that we can sustain and maintain the projects that we've developed so they continue to add value. We're also looking at academic partners as a potential for transition, state partners, as I mentioned, federal agencies, and we're also looking at the private sector. So we're forming are working closely with the private sector as well. So just a quick description of the process that we've undertaken for identifying needs. So we've really kind of used a river basin, major river basins in the Western US, as a way to bound our needs assessments. We looked at 3 different ways to conduct these needs assessments and identify the needs. The NASA approach is to top down, we measure snow, so let's go out and find out about snow or what have you. So rather than taking a variable approach or even working with a single agency, we felt that by working with basins, we would get a better understanding of kind of water as a system in the basin, but also management of that water as part of that system. We've completed 4 basin studies. I've highlighted the Rio Grande. Upper and Lower Colorado, Columbia, and the Missouri. We have the Arkansas White Red Basin Study coming up in FY24, and we're hoping to be able to also do the Great Basin in FY24 as well, and that'll complete all of our basin assessments. We've not done an assessment of the California, just because we've been working with the state of California and that region for so many years. We felt that we already had a pretty good handle on the needs in California. So just a sample of some of the needs that we've highlighted. Now, these needs haven't been prioritized in any way, shape, or form. You'll probably see that some of them are more specific, and some of them are very high level, and some of them are kind of loosely associated with water management. For example, land use and land cover mapping is maybe not very specific to stream flow forecasting, but still it was one that we've heard. So we've made no attempt to prioritize or in any way filter these needs. This is what we learned, a sample of what we learned in the Colorado. And then we tried to connect them to current and planned capabilities that can be brought to bear to address those needs, so that we make sure that we connect back to NASA. We've got a fair amount of sensors that are currently flying, as you recall from the previous slide. And then those that are in blue here on the right side, these are upcoming missions or modeling activities. They're not all missions. The GPM and SPORT and GMAO are all modeling activities that support various needs that we've identified. And then I just want to go over a couple of very broad examples of some of the projects that we funded and some of the work that we've done based on the needs that we've identified. So we've identified, just very broadly, a need for improved information about snow, including snow water equivalent as an in runoff to improve runoff forecasting and stream flow forecasting. And then just a couple of examples of some of the capabilities that the WWAO program, as well as NASA Water Resources Program, have developed. Or may be familiar with the Airborne Snow Observatory. Snow Today is a snow data system that we've been developing with the University of Colorado. It's about to go to a NASA center, so it'll be permanently maintained. We're working on a next-gen stream flow forecasting effort with USDA NRCS, and then near real-time snowpack estimation. This is work that we do with Colorado, University of Colorado, and the state of California. And just, I guess, kind of an overview of some of the impacts. The Airborne Snow Observatory was spun off into a private company, and it's continuing, and it was actually WWAO who developed their business case and their business plan, so we helped them create that company. And now they're delivering snow water estimates to both the state of California and Colorado, and to the Bureau of Reclamation and to the Colorado River Forecast Center. The CU Boulder team, I mentioned this. This is they're providing near real-time estimates of snow water equivalent for the state of California. And then I talked about the work we're doing with NRCS. It's kind of interesting. It's some modeling, machine learning, approach for stream flow forecasting in basins in the Western US. Promising. And then just quickly, droughts. This is just some of the work we've done around drought. We all know the drought is continuing to plague the Western US, especially the Southwest. So we've worked with Colorado, Rio Grande, Missouri, and with tribal communities. And we've developed some capabilities to support kind of drought monitoring and resilience. And just a couple of examples. One is the drought severity tool, which was one we developed with the Navajo Nation. You can barely see it, I think, in the top map, but there's a map of the Navajo Nation there that inserted into the map with estimates of drought severity. And previously, emergency relief was not allocated. It was allocated the same to everyone, no matter where they were in the nation. But certainly there were areas of the nation where people had more need. And so through the use of this tool and through application of this tool by the Navajo Nation, they're able to more equitably allocate emergency relief. At the bottom is the Western Land Data Assimilation System work that we've done with the Colorado Climatologist Office. They really are currently using a model called the Land Data Assimilation System that was developed by NASA, but they wanted a higher resolution version of that. And so we worked with them and with the modelers, the NASA folks who developed this model, and we provided a higher resolution version of this model that we're calling Western LDAS because we've created it for all of the West. And we've delivered that to the state of California, to the state of Colorado, excuse me, and they're installed it and they're running it and they're using it in their own processes to for their state's weekly drought reports. Just to highlight, I'm happy to provide more information as well on some of the other things we've done. And then this, because I think it's probably more relevant to this group, this is a project that we funded in the Columbia River Basin. It's not finished yet. We're expecting this to complete by the end of the calendar year. This is work that we're doing. It's led by the University of Idaho with Washington State University. They're working with USTA and the US Forest Service and the state of Washington to improve. This is really for post-wildfire situations where you've got impacts to a watershed. And they're working to improve predictions of water yield and sediment loads in the Columbia River Basin. They're using a model it's open source, it's developed, and they're extending the utility of that model by incorporating satellite-based information into that model. And we're really excited about this project and look forward to their final report. Now, I wanted to talk a little bit about NASA's, oh, I have ecological twice, sorry, typo, Ecological Conservation Program. So the Western Water Applications Office is under the Water Resources Applied Science Program. And this program is a separate program, but I think there's a lot of overlap and perhaps relevance for this community. So I want to make sure that I highlight this program as well. So the Ecological Conservation Program really tries to promote the use of Earth observations and models. I don't want to read this to improve resource management and to inform management strategies. They work with a broad range of folks, land and marine and freshwater. They do work in freshwater, and they especially work with folks who are involved in conservation and ecosystem management. And I've just highlighted a couple of their projects that I think may be of interest. They have many more projects that you may be interested in, and happy to arrange an introduction to this group as well. So this is one of their projects. This is the based on kind of understanding recovery and adaptive management for the Lahontan cutthroat trout. So this species is a native species to the Lahontan Basin, which covers northern Nevada, eastern California, and Oregon. These fish used to be plentiful, and now they're threatened. And in particular, they live in these isolated populations throughout the arid western US. And these populations are scattered over a wide area, which has increased the threat of localized extinction. And so this team from University of Georgia and Trout Unlimited evaluated the status of several populations across the known range of the fish. And they've developed a model called the multiple population viability analysis model that incorporates satellite data, aerial imagery, and then an environmental model to estimate factors that affect the fish, such as stream flow and vegetation greenness. They've also developed a population simulator that takes input from the model that they've developed, so that you can in real time go through various what if scenarios to kind of get an understanding of for future planning. So I've put the link to the tool here. I've worked with it, not worked with it, but I've gone through and run some scenarios myself, and it's an easy to use tool, and it may be of interest to you. Also notable that they've partnered with the Nevada Department of Wildlife for this project. Another project, this one is based in California, that the ecological conservation team has funded, is a project that to assist, I guess, migratory birds in California, and in particular in the Central Valley. So migratory birds can fly thousands of miles, as I'm sure folks here know, and particularly in the spring, north in the spring and south in the fall, on their annual migrations. And so this is an effort to restore some of the lost natural wetlands that they use on their journey. And the project uses NASA Earth observations and citizen science to inform a nature conservancy project called Bird Returns. And it's a project that's been underway since 2014 in California. And they ultimately pay rice farmers to keep their fields flooded for a few extra weeks. And by doing this, they create 60,000 acres of pop-up habitat for migratory birds to make up for the deficit in habitat that's been created by farming in the Central Valley. And the farmers actually recognize the benefit of this project, and they feel that it's mutually beneficial both for the birds and for the rice industry itself, because it allows them to incorporate ecological benefits into their industry. It's a project that brings together a team of collaborators. It incorporates expertise from the Cornell Lab Ornithology group, who've developed an app called eBird that kind of is a citizen science app that to instantly upload information on birds that people are seeing. And they combine this data with data from NASA, Landsat and MODIS, and then work with Point Blue Conservation Science to develop this model to predict where the birds are going and where the birds will need a pop-up habitat the most. It's a side benefit of this project for water resource management is one of the challenges in the San Joaquin Basin, in particular in the Central Valley, is subsidence due to overdraft of aquifers. And because the rice farmers are flooding their fields, they're being paid to flood their fields, it's kind of a nice test case to assess how quickly water is infiltrated into the groundwater, and how well or how quickly the aquifers can recharge. So there's sort of cross benefit. And this is kind of ties into water management in California, especially the flood managed aquifer recharge program led by California Department of Water Resources. So a nice cross benefit between water resources and ecological conservation. Lastly, this is talk about a project that kind of meant to impact the, measure the impacts of rewilding beavers in Idaho. This is a project that's led out of Boise State University, and they're collaborating with Utah State. The hypothesis is that rewilding beavers builds resistance of watersheds to drought and wildfire. So they've developed a tool called the Beaver Restoration Assessment Tool that they already had, and they've used remote sensing products. They've incorporated remote sensing products into that tool then to measure the resilience of ecosystems in dryland, especially in dryland systems. So they use a combination of optical data and radar data plus machine learning to quantify change over time and also to consistently sort of monitor large, very remote areas. They've honed in on a use case in 2018. There was a wildfire in Idaho. And there also has near where there's a beaver translocation site. And this provided just a great opportunity for the team to assess, different scenarios using the tool that they've developed and to look at the benefits of rewilding or not, and the impact to watershed resilience over time. And I should say that the results were promising from that project. The project is still going, it's not completed yet, but what they've learned so far is that the rewilding of the beavers in this one area in Idaho creates more areas of persistent water in the watershed going in the long term. So I just wanted to touch again very quickly on just some upcoming exciting new missions, some which have recently launched and some that will be launching in the very near future. One is a mission called PACE, Plankton, Aerosol Cloud, and Ocean Ecosystem Mission. We have a target launch date of 2024, and we expect that if people are interested, for example, in water quality, this is an opportunity for ocean color type observations or water color type observations to assess potentially harmful algal blooms in rivers and in the ocean. NISAR, which is a radar sensor, a lot of potential benefit here both for water and ecological conservation, is set to launch in 2024. And in particular for water resources, we recently launched the Surface Water and Ocean Topography Mission. And this one measures surface water extent and height at higher resolutions than we've been able to do before. So we'll be able to get to rivers that are, they're still fairly wide rivers, we think 50 meters wide, but it's at a higher resolution than we've been able to do previously, especially useful in very remote areas. And then lastly, Landsat with a thermal instrument. The workhorse is still going, and we had Landsat 9 that was launched in 2021. I hope I haven't gone over.
No, not at all, Stephanie. You have all the time you need.
Questions?
Thank you so much. That was really informative. I appreciate those case studies. That kind of helps encapsulate the broad array of topics that you all cover. So thank you for that.
You're welcome.
So while I let everybody kind of digest what you've presented and hopefully
There's a lot.
I did have one question for you just to kind of
Sure.
kick things off. So I know that our website was down when you tried to look us up, but we are a diverse collaborative. So we have everything from federal and state and municipal government organizations to tribes and non-government organizations and Audubon Society. So we have 16 signatories right now. And so as a diverse collaborative, I was wondering, how can we participate in the connections process that you described for the WWAO?
Sure. Well, I mean, I think that in some ways that makes your group a boundary organization. And so we've found that it's very effective for us to work very closely with consortia and other, boundary organizations. We work very closely with a group in the Colorado River, the Colorado River Climate and Hydrology Work Group, which is a phenomenal way for us to kind of be involved. And we don't always make all of the meetings, but when we can, we do. And we keep in touch with that group so that we have an understanding of kind of evolving needs in the Colorado River Basin in particular. And so, we're happy to, if you'd like us to be at meetings, we can be at meetings. We can also make connections to the ecological conservation program, because based on what I saw, I think that that's a really relevant program for your group. So happy to make those connections. We'll come to meetings and participate, even if that's just in listening mode.
That's great. Thank you. I appreciate that. And for my part, I'm offering to to be the liaison if necessary for that. I
Oh.
can certainly hook you up with the right people in our group. So
That would be great. And what I would do is connect you with Sharon Ray, who's our engagement lead.
okay, fantastic.
Yeah, that'd be fantastic. And I didn't mention it. I talked about the basin assessments. And so in some ways, we've kind of done this peanut butter over time across the Western US, the peanut butter approach. And we focus in a basin, we fund projects in a basin, and then move on to the next. But it's really important for us to stay connected in those basins where we've been. And so it could be that this group would, offer that opportunity for us. So we would very much appreciate continuing the dialogue and just being a part of it when we can. But another thing that I didn't mention is that once we complete our needs assessments across basins, then at that point, we'll be looking at all of the needs that we've identified, the use cases that we've identified, and identifying those common needs that keep coming up across the entire Western US. And from there, then we'll start taking what we do to scale. So we'll sort of circle back to the whole basin once we've completed our assessments, which we hope to complete at the end of FY24.
That's great. Thank you. Does anyone else have any questions for Stephanie? And I can't see everybody, so Zoe, if you could help me out.
I'll stop
Oh.
sharing. I hope people got the.
Oh, thank you. Yeah, we have a question from, go ahead, Dagmar.
Hi, Stephanie.
Hi,
Thanks,
Dagmar.
thanks for that presentation. I was wondering if you could give us an update on the next steps after the receipt of the RFI for the Rio Grande. Is there, what's the schedule for it? What kinds of new information are you receiving? And will there be a call for proposals after that? Or will you be meeting with submitters to try to further explore their ideas, or what's going to happen next there? Thanks.
Great. So what we've done, so it's kind of WWAO is kind of an interesting office. We've been told to experiment with program practices by NASA and also to be nimble. So we've tried different approaches to funding projects. In the Columbia River Basin, we've started this RFI process and funded kind of smaller projects that have been stakeholder led. And that would be something that we would continue to do in the Rio Grande. So we've received a good number of responses, as I said, and we're reviewing those right now, and both for technical and relevance to the program. Once we've done that, then we would ask, based on what we learned, there may be follow-up questions for the folks who've submitted responses. Maybe we need some clarification to better understand. We may do some teaming, especially where we have responses that are very similar. Or we have some responses from some of our NASA folks where we don't have a partner in the region. And so we're interested in kind of making those connections as the next step. So once we've gone through that process of review, of answering questions and teaming, then we will ask the folks who responded for proposals, and we contract those proposals directly through JPL. So they're not funded through NASA. They're funded through JPL and through our contracts office, which allows us to have a little bit of a faster process and allows us to be a little bit more nimble than a regular NASA office. I should say that JPL is the only federally funded research and development center that NASA has. And so it's a good thing and it's a bad thing. But in this case, with our contract processes and our ability to get things funded and get things moving, it makes it a little bit easier. I'd like to have projects funded and underway by the start of the calendar year. We are planning our annual meeting in February, March, and so I'd like to have those projects up and running by then. Does that answer your question, Dagmar?
Yeah, thanks. That's a very ambitious schedule. So
I know.
yeah, good luck.
Thank you.
And just also like to highlight, and the reason that we know each other, you and me and both John and Sarah Branham, who are on here, have been working together in the area of ET in the Middle Rio Grande. So that didn't, make your slides, but just highlighting that you're already working in the basin with us, and then also with the state of New Mexico, also on a number of projects related particularly to, I think, evaporation and ET. So maybe you'll say a word about that before you move on to Andrew. Thanks. Nice to see you.
Sure will. Thank you for that nudge, Dagmar. I really appreciate it. And yes, I should have included, I have an ET slide in backup. We have been working with the state of New Mexico, the Office of the State Engineer, as well as Dagmar's office for a number of years on various ET projects to one is the next gen, no, is it the next gen ET toolbox?
That's right. Yeah.
Satellite-based estimates of evapotranspiration to the Bureau of Reclamation for the state of New Mexico for improving understanding of water use. And then we've also worked with the Office of the State Engineer along similar lines. And we've got a project that was funded by WWAO with the Office of the State Engineer. And again, this is Josh Fisher, Dagmar, Josh, and Gregory, to provide estimates to New Mexico State of high resolution evapotranspiration. And this work was, then there's some follow-on work that was funded by NASA Water Resources Program to fully transition that effort to the state engineer's office. So with the work with Bureau of Reclamation, it's been a little bit challenging to transition that work over for sustained use. And we've explored a number. I think our original plan was that we would deliver the code to the Bureau of Reclamation, but we had some challenges with that. So we looked at other organizations who could potentially take it on and run it.
It's now being hosted by the Middle Rio Grande Conservancy District.
Yeah.
Yeah.
And they've got it. It's and we're working through some just the what we need to do to get it up and running. Anything else to add, Dagmar or John or Sarah?
Not me, thanks. Thanks for describing that.
Sure.
And the work we're doing.
Thank you so much. That's very helpful to know the existing connections here. Andrew, do you want to go ahead and ask your question?
Sure. Hi, Stephanie. Thanks for the very, very interesting overview of the great work that NASA is doing. On the topic of connections, real appreciative to the collaborative for a lot of reasons. We're extending our partnership with that group. But yesterday we had a second day of a workshop here at our Whitfield Wildlife Conservation Area on the banks of the Rio Grande outside of Berlin. And first off, I just love the connective dots with high resolution ET and that approach. We're really trying. We had the biggest fire in Valencia County move through the Bosque last April, and so that's kind of kicked us in the backside to try to reduce the severity of fires and then have a thoughtful science-based approach for the restoration side. A big part of that is pushing forward a plant palette that's climate and fire adapted. Preparing us for the hotter and drier weather coming our way, and there's just this dearth of really actionable, plant information that tells you all the different components. So we've got a great application. We just got pushed to full proposal stage for a climate adaptation science center plant matrix. So fingers crossed that works. But I wanted to share with you the original reason I raised my hand in this afternoon was to share with you another one of the tangents that we talked about in this workshop, and it comes up in a lot of the collaborative conversations that we're having is talk about lack of actionable data. The whole arena of ecological services, environmental services, e-flows. I just continue to be depressed by how our ability to put the environmental benefits that our restoration work is doing, not just river related, but floodplain and other environmental services into a reasonably agreed upon economic expression. So I like it or not, ill-fitting or not, it seems like my lay audience in my served communities, they want to know the dollars and cents of why, if we do this, what's the economic benefit? How does that translate into a capitalistic version? So I guess with that as a little bit of a preamble, what are your thoughts on that front? I mean, it sure seems to me, I've been in this conversation for 30 years and I haven't seen a whole lot of advancement in something that the broader group of practitioners can lay into and respond to this common Joe public's request to say, well, how is that economically relevant to me, your restoration work? So help me on that front, would you?
Yeah, well, I can maybe speak from the water side to say that it's hard to do. And so we've done 3 economic assessments, and we've worked with Resources for the Future. We've worked with RTI to conduct those economic assessments. I think that, we as, a science community, we know that what we're providing is valuable, but for water in particular, it's hard to demonstrate how providing high resolution ET or better snowpack data actually connects to those water molecules. It's hard to make that precise connection. And so we've been, I think that where we've had success in estimating and doing value of information studies, it's been when we've partnered with organizations that actually know how to do this. So RTI was one. They just turned out to be. We worked with vineyards in California to assess the value of information that improves their irrigation practices, and it's hard to say that well this led to more productive vineyards, but it's been very helpful working with RTI because they've done some of that for us. It's kind of a and I'm happy to provide more information on that work if that's helpful, and the work we did with Resources for the Future.
Sure, that'd be of interest. I mean, it strikes me. Yeah, there are no silver bullets. It's really different, especially in the altered riverway context. I mean, some of the water quality conditions and some of the best expressions of this work I've seen is when you try to say, well, if you keep a river alive and it goes through its floodplain, you're having this, the self-cleaning mechanism is being supported. But that's the exception where I've seen some data points in that kind of conversation. So I think all of us, no matter what kind of front we're taking, what entry point we're having in the conservation field, would be better served to have some set of talking points that we could talk about kind of the economic side of the work that we're doing.
Yeah.
So thank you for your time.
Yeah, I can also follow up with Keith Gaddis, who's the program manager for the Ecological Conservation Program. I don't know whether they're doing they may be doing similar value of information work that we've been doing. And that might be helpful as well.
All right, thank you for those questions, Andrew. That was great. Does anyone else have any questions for Stephanie? And Stephanie, I saw you shared your contact information on that last slide. Is it okay if people contact you directly, or would you prefer that we pool our needs and, and present a list?
It would, you could, it's okay to contact me directly, but it would probably be more efficient to pool the needs.
Okay.
You know,
Well, we'll definitely follow up with our folks after this, and hopefully some more folks will be able to watch the seminar on our portal once it's posted, and maybe we'll get some other questions and comments.
yeah, and I'll provide you with the slides as well. after
Okay,
I-
great. Thank you so much.
Thank you, Catherine. Thank you, everyone.
All right. Thanks, everybody.
Take care.
Appreciate your time, Stephanie.
Thanks, Catherine. Thanks, Stephanie.
Thank
All right,
you.
thanks,
Bye.
Andrew.
Uh-huh.
Have a great
Thank
day.
you.
Hi, Zoe.
Thanks, everybody.
All right, we can stop the recording.